So finally, let's get started with our first key pain point, our first area of improvement, and that would be names. In this module, we are going to focus on naming things, so on assigning good names. We'll focus on all the nameable things in development, which would be variables, constants, and properties, functions and methods, and of course also classes. We are going to explore why names matter exactly and how good names can help us. We'll then, most importantly, dive into rules and concepts for assigning good names, and we'll compare these names to bad names to really see the difference. And of course, as promised, we'll have plenty of small examples and demos, and also a challenge for you at the end of this module to apply what you learned. When it comes to naming things in development, there is one simple overarching rule, and that would be that names should be meaningful. This really is all. This is the core idea. Whenever you name something, no matter if that's a variable or a function or a class, the name should be meaningful. It should transport what's stored in a variable or what a function or method does without having to look at the code inside of that function or method, or without exploring the values stored in a variable. For example, consider this code snippet. It's not a lot of lines, but it's really not clear at all what's going on there. Const as equals new main entity, as process, if login. What are we doing there? What's this main entity? What does process do? And what is the value of login? Is it a function for which existence we check? Is it a Boolean value? Is it a string, an error code? We don't know at all. And now consider this alternative. It's the same code, but it's way clearer. It's now obvious that we are creating a user, which we are then saving, maybe to a file or to a database. This might not matter to us, but we are saving the user, and we got is logged in instead of login, making it clear that this very likely holds the result of checking whether that user is logged in or not, so a Boolean value, true or false. This is now very readable and very easy to understand, even though it's the same number of lines. The only difference is that now we have meaningful names. So picking good names in your code really matters. If we have well-named things, variables and so on, in our code, we allow our readers, so the people reading our code, to understand that code without going through all the details, without diving into it in detail. Consider these examples. In all three examples, it's pretty clear what this code does, even though we don't know the details. We don't need to dive into the rest of the code just to understand these snippets. That's why names matter. Now, I will emphasize right away, we will not always agree, because obviously there is more than one way of naming something. In this course section, I'll explore the rules we can follow to come up with good names, but ultimately you will still always have more than one option. For example here, this is readable, I would say. We are probably creating some admin user, but this here is also readable and not necessarily worse. You could definitely find arguments for either of the two names, and it's up to you how you want to name something in such cases. There are, however, also names which clearly are bad, and that's what I'll focus on in this course section, so that by the end of the section you have a clear understanding of what makes up a good name and what makes up a bad name. And then, of course, it's up to you to pick which good name you want to go with. So, before we explore any bad or dirty code, let's dive right in. How do we name things correctly in our code? Well, let's differentiate between these three main blocks which I outlined, and let's have a look at the different rules. Variables and constants, and of course also properties and objects, which would be in the same category, are all data containers, you could say. We use them to store some data. That could be some data entered by a user, for example, in a web application. That could be the result of validating that user input. It could be a list of products, a single product, anything like that. Here, for the names of these variables, constants, and properties, we typically want to use nouns or short phrases with adjectives which describe what's inside of the data container. For example, something like user data or just user. Something like is valid if we store a boolean. These would be good names, and we are going to see way more examples throughout this section. No worries. So that's how we want to name our variables and constants and properties. We want to describe what is being stored in them. Now, when it comes to functions and methods, the idea is a different one. Here, we don't store something in that function. I mean, there is code inside of it, but that code executes once a function is called, and therefore, in the end, functions and methods are, of course, commands which we can execute on demand, or we calculate values which we return. So they are commands or calculated values, you could say. For example, we could have a function which sends data to a server. We could have a function or method which validates some user input. And therefore, for function and method names, we typically go with verbs or, again, short phrases with adjectives. So here we could have something like send data as a name for the function which sends data to a server. Or input is valid for the validation function. Maybe also just is valid. This would also be okay. So here we could have the same name as for the variable on the left, because we want to describe a value which is produced by the function here then. Though I will say that booleans are a special case here. If we had a function which produces a user object, for example, we might want to call that function getUser or createUser or something like that. But again, you will see more examples for these different scenarios throughout this section. Now, when it comes to naming classes, it's important to understand and keep in mind that we use classes in our code to create things, to create objects. For example, a user object or a product or an HTTP request body which we want to parse, something like this. And therefore, for naming classes, we also use nouns or short phrases with nouns, so simply multiple nouns combined with each other. Something like user or request body, which would be these multiple nouns being combined. That's how we want to use classes. And if you keep these basic rules in mind, you already got a good foundation for naming your code correctly, for naming the things in your code correctly. But of course, we're now also going to explore the different niche cases, variations, and then also how to pick the best noun for a given value being stored in a variable, for example. Because using a noun is just a start. Of course, you want to use the best noun, which best describes what's inside a variable or what's inside a function and so on. So that's, of course, what we're going to explore throughout this section. Now, before we dive into the concrete examples and the different variations and so on, we also have to stop at the important topic of casing. In programming, we got four main ways of writing our names, four main casings. And that would be snake case, camel case, Pascal case, and kebab case. Now, snake case looks like this. Is valid, send response, where multiple words are separated with an underscore and everything is lowercase. And for example, you use snake case a lot in Python. There, you use it for variable names, for function names, and for method names. And that's what you saw in the initial examples in the first course section already. Now, Python uses snake case. Many other programming languages, like Java or JavaScript, use camel case, which looks like this. Is valid, send response, the same name, but now not with an underscore between words, but instead there is no separation between words except for the starting character of the next word in line. The first character in the name is always a lowercase one, like the I in is valid and the S in send response, but then every word in that phrase starts with an uppercase character, like the uppercase V in valid and the uppercase R in response. Again, this camel case notation is used by many other programming languages, but it's used for the same things as Python uses snake case, and that would be variables, functions, and methods. Now another notation which we know is Pascal case. It looks like this, and this is used by many programming languages, for example by Python and Java and JavaScript, for class names. Class names are typically written in Pascal case. And when it comes to kebab case, it looks like this, and we, for example, know this from HTML, where we can use it to assign names to custom HTML elements we might be building. Now, these are the four main ways of writing things, and mostly it comes down to conventions, when to use which notation. I outlined the most important conventions here. For example, for Python, we use snake case for variables, functions, and methods. And style guides for your favorite programming language typically tell you which notation to use for what. I want to emphasize, of course, that no matter which casing you use, the name in the end is always the same, just the way you write it is different. And therefore, again, which programming language you choose does not really have an impact on how to write clean code. This is just an extra convention you should keep in mind, because of course following language-specific conventions is also a part of writing clean code. So let's now dig a bit deeper, and let's start with variables, constants, and properties. How should these be named? We can differentiate between three main kinds of values which are being stored in them. Our values could be objects, and this includes lists or maps or any other more complex data structure. Our value could be a simple number or string, or our value could be a boolean. And you can already tell by the color coding here that there seems to be a difference between booleans and the other kinds of values. Now, if your value, which you store in a variable, constant, or property, is an object or an object-like thing, then the name which you assign to your variable or property should simply describe the value. So if you are storing a user object in your variable, name the variable user. If you are storing an object which describes a database and offers database operations, you might want to name the variable database. If your value is a number or a string, so some text, then you also just want to describe the value. If you have a variable that holds the name of a user, you might just want to call it name. The same, of course, if it's a property in a user object. If you have a variable or property which holds an age, you might want to call it age, just like that. Now for booleans, there is a special case. For booleans, your name should simply be a question that can be answered with true or false. So you might name your variable something like isActive or logged in, because that can be yes or no, and therefore true or false. You are active or you are not. It's a either or choice. So for booleans, we want this is something naming or names like logged in, which also can be answered with yes or no. Now you might want to consider providing more details and more information where it makes sense, but you don't want to introduce extra redundancy. For example, if your user in a certain branch of your code is always an authenticated user, you could consider naming that variable authenticated user to make it really clear to everyone who reads that code that you're only acting on an authenticated user here. If it's a customer, you could name it customer instead of user to have this more specific name. If it's a SQL database, you could use that as a name to make it really clear which kind of database you are working on. If you store just the first name of a user in a certain field, you might want to name it first name instead of just name, to be more specific about the kind of name being stored in there. On the other hand, I would argue that age is already pretty specific, so you probably can't be more specific there. So it's not about making your names as long as possible, but just about making them as clear and as easy to understand as possible. And sometimes shorter is better, sometimes longer is better. Obviously, this is also something which will come with experience, but also with help of the demos and exercises you will see throughout this course. Now for booleans it's the same. You can add more details if it makes sense. For example, if isActive refers to a user, you could name it isActiveUser. Logged in, on the other hand, will typically always refer to a user. So for example, using user is logged in instead of just logged in is longer, but not necessarily better. So now that we know how to name variables, constants, and properties, let's see more examples and let's see different variations of names. For that, we will consider what's being stored. We'll then have a look at bad names, at okayish names, and at good names. And let's start with the good old user object again. Let's say we have a variable in which we store a user object. And the same would be true if it's a constant or if it's a property. And let's say that user object is simply the combination of the name of the user, the email address, and the age. Now what could be bad names here? Now bad names for this kind of variable would be something like u or data. U is simply very short and unspecific, and data is also not very specific. These variables could contain anything. It's not clear that they hold some user object. Names which are okay could be user data instead of just data, or person. The problem with user data is that it might have some redundant information attached to it. I mean, if we have a user object, it's clear that it contains data about that user, so we probably don't want to name the variable user data. And for person, that might be too unspecific. It can make sense. I will not say that it's always wrong, but often you might be working on a customer, or on an author, or an instructor, or an administrator. So maybe you want to use these specific versions then. If we would not be storing a user object here, but let's say we would just be collecting data a user entered in some form, and we have a mixture of the entered values and of validation results of us validating these inputs, then we could have a user data variable which holds this bag of entered values and validation results. There, something like that could make more sense, because it would not be the finished user object then, but some intermediate object between collecting the values and creating the user. So that's something to consider, and I'm bringing this up here just to make it clear that a name which might be okay in one scenario might be a good name in another scenario, and vice versa. Just the bad names are really often very bad. So therefore good names could be user, or as I just said, something more specific like customer. User is pretty descriptive and clear, and customer is even more specific, which often might be the better option to make it really clear which kind of user that is. Of course, if you have an application where a user is really just a user and not necessarily a customer yet, then there is nothing wrong with going with just user, which is why it's listed under good names here. And with that, I got a first little exercise for you. Let's say we're now validating some user input, and it's the result of this validation which is being stored in a variable or in a property. How would you name that? Pause the video for a second and think about bad, okay, and good names, and then we'll have a look at the examples I came up with. So what could be some bad names for this? Well, again, just using a single character is pretty much always bad, with some rare exceptions. So we could use v for the validation result, or something like val. The problem with v is that it could be anything. The problem with val is that we could also think that it stands for value instead of validation result. So these are too unspecific and don't tell us anything. When it comes to okay names, we could have something like correct or validated input. The problem with these names is that they don't imply that they hold true or false values. Correct could be holding any kind of value. It could be true or false, but it could also be some text or anything else. And validated input could hold the value which was validated instead of the validation result. So better options could be is correct or is valid, or something like did validate successfully. These would be names which are descriptive and where it's clear that we have a true or false value stored in there. Now, there will be more examples throughout this course, but this hopefully gives you a first idea on how variables, properties, and constants may be named. So how should we name functions and methods then? Well, here we can also differentiate between functions or methods which do perform some kind of operation. And that really can be any kind of operation. It can be an operation where data in an object gets changed. It can be a calculation which returns a value. But the other kind of function we can have a look at is a function which computes a boolean specifically, so which returns a boolean value. Now, for the first case, that we have any kind of operation, the function or method name should really just describe that operation. So for example, getUser makes it really clear that we're getting some user, maybe from a database. Response.send makes it really clear that we're probably sending the response on which we execute this method. Now for the Boolean case, we again want to answer a true or false question, just as with the properties and variables and constants. So here, as an exception, our function could not describe the operation, but instead the result. And this is really only the case for Booleans, where you want to do that. So here your method or your functions could be named isValid or something like a isPaid method on a purchase, to return true if that purchase was paid and false if it wasn't. Now, just as before, more details are always great unless they are redundant. So for example, if we have a function which retrieves a user from a database, but it does so by identifying the user by email, we could name the function getUserByEmail to make it really clear that it's not fetching a user by ID or by any arbitrary criteria, but that it's always the email. Now for response send, on the other hand, this already is pretty clear. Something like response.sendResponse simply wouldn't make a lot of sense. It's clear that we're sending this response. For Booleans, just as before, we can also add more details if it makes sense. For example, if we have a function which validates email addresses specifically, we could name the function emailIsValid instead of just isValid. On the other hand, again, for purchase is paid, this is already pretty clear. More details could be added in some use cases and scenarios, but in most scenarios, it's probably good like this. So therefore, it's again time for some specific examples, now on functions and method names, again with bad, okay, and good names. Now let's say we have a function that saves a user or saves user data to a database. How could we name this function or method? Well, bad names would be something like process or handle. This is very generic. These could be doing anything. Yes, it could be processing or handling a user, but we could also be processing an order. So this is not telling us anything. In addition, it's not clear whether process means save or update or delete. It could be anything. So this is definitely very unspecific and not the naming you want to use. Now, when it comes to OK names, we could have something like save or store data. Now, the good thing is that now it's clear that something is being saved, but it's still not necessarily clear what is being saved. Of course, if save is a method on a user object, then it's way clearer, and then save is perfectly fine. But if you just have a function called save, which is not called on an object, but which instead, for example, receives an object as an argument, there might be a better name which you can choose. For example, save user, or you use what I just said, and you instead make that a method on a user object, which now again makes it very clear that it's probably this object which is being saved. Here the intent is very clear, especially if you use the method approach. And again, just as before, we are going to see more examples throughout this section. But before we do that, it's again time for you to pause this video and try this on your own. Let's say we have a function which validates some user input. How would you name that? And by the way, it doesn't necessarily have to return true or false. So how would you name this function or this method then? Well, bad names again could be process or now also save. Validating is not the same as saving. We might save after validating something, but first we validate it, and there nothing gets saved. So this is unspecific in the case of process, and even misleading in the case of save. Now, better names could be validate save or check. Validate save could imply that we do both validation and saving, so it's still not ideal, but if that is what we do, it's okay. Check is okay. It makes it clear that we're checking something, but it's also not really specific, and it leaves us guessing. Both names leave us guessing on what's happening exactly. So better names could be validate, or if true or false is returned, is valid. Validate could be called if we are not returning true or false, but if we are, for example, throwing an error if the validation fails. Is valid, on the other hand, is a great name if that function does return true or false. So now we had a closer look at naming variables, properties, and functions and methods. Let's now have a look at naming classes. Here, we don't really have different cases to consider. We should always describe the object which is created when we instantiate the class. And that's important. Keep in mind that classes typically are used to instantiate something. You can have static classes with static methods, but typically you instantiate something, and therefore the class name should reflect which kind of object gets created. Hence, classes might be named something like user or product if they reflect these objects. You can, as always, provide more details if it makes sense and doesn't add redundancy. So your user class could become a customer class, your product class could become a course class if your product is an online course. You can also use more than one word for class names, but you should avoid redundant suffixes, like database manager. It can be intriguing to sometimes use names like this, but always consider that classes are typically instantiated. And if you do that, what is the instance of a database manager? If that's a person in your company, the manager who manages all the databases, it maybe makes sense. But if it's an abstract thing in your code, which just manages all the databases your application uses, there might be a better name available. Using names like this might make sense if it's mostly a static class full of utility methods or anything like that, but typically you want to avoid them and you want to go for the clearer names instead, which can also be instantiated. And that's really all you gotta know about classes. They should describe the object which is built with help of the class. So now it's again time for more examples, this time focused on classes. And again, we got these three kinds of names, and the question is which kind of object is described. And let's say that is a user again. How should the classes be named then? When it comes to bad names, we could use something like uEntity or Object A. These, again, are very unspecific, they could hold anything, these are not the names you want to use. Better names would be something like UserObject or AppUser. These names are okay, but actually we have redundant information in there. Of course a user is an object, and of course a user in our application is an application user. So using these names might not make too much sense unless you have a very good reason for doing that. Now good names could be just user or the more specific kind of user, admin, or also customer, and so on. This is fine and specific enough, or in the case of admin, even very specific. So these are great names to use. And that of course again means that it's now time for you to practice this. Again, take the chance to pause the video and then come up with some names for a database, which should be described by a class. So let's say you are creating a class which then has methods which you can use in your code for connecting to a database and for sending queries to that database. That would be a thing you definitely have in a lot of applications, and the question now is, how could you name such a class? Here are some bad names. The problem with these is that data and data storage are very unspecific or even describing the wrong thing. Data storage doesn't have to be a database. It could also be a file storage or a storage in memory. So this is very unspecific and even a bit misleading. Better names could be DB or just data, but it's still not 100% specific. Especially data is almost a bad name because data again could be anything. So this might not even be okay. Now, good names, on the other hand, are of course database or the specific kind of database which is being created. If you have a SQL database and your class has all the methods it needs for interacting with this kind of database, SQL database, of course, is a great name. Now, of course, no good rule comes without exceptions. So all the rules I walked you through over the last lectures, of course apply, but there are a couple of exceptions you might want to be aware of. And you see one right here. This is a Python code snippet using the datetime library, which is part of the Python standard library. So it's a built-in module shipping together with Python, which you can use if you need datetime specific functionality. Now I'm calling datetime now here to get the current timestamp of today right at this minute where this code executes. And this gives us a date object, which we then can format to a string with certain formatting rules by using the strtime method here. And as you can clearly tell, these names actually violate what I taught you over the last minutes. Now is a method. As you can tell by the brackets, we are executing it. It's a method, not a property. Hence, it sounds like a property. It's not describing a command, and it's also not returning a boolean, where something like is now would be acceptable. Instead, it's just now, and not something like get now or get current timestamp. No, that's not how it's named now. And since it's a built-in library, you of course can't change it. This was defined by other people, you can't override it. The strtime method here also has a rather strange name. I'm not sure if it sounds like a command because it's pretty hard to tell what this should be. I can tell you that strtime should stand for string from time because it returns a string from a datetime object, but of course this is really not intuitive and therefore in my opinion not really a great name. In addition, even string from time is not really a command, but again more like a property name. Now again, this is built into Python or into a Python core library, so you won't be able to change it. It does not mean that you have to use the same naming in your code though. You should try to follow the rules outlined over the last lectures unless you have a good reason for not doing so. For example, because everyone in your team agrees that you want to follow a different naming convention. And of course, naming conventions can also differ across languages, though even in Python, you typically should not follow the naming you see here on the datetime library, because I would argue it is not super readable. Now is okay, but strtime, it's totally unintuitive. You need to hover over that to understand what it does, and even that might not be enough, so you might need to dive into the official docs to understand what it does. And if you just explore the available methods here with auto-completion, you see these methods don't tell you anything. So it's really not easy to quickly see what you want to call to achieve a certain result. So that just proves my point that naming matters and that good names matter. And I would argue these are not great names. And of course, as I said, there's nothing we can change about it, but we also don't have to copy it into our code. Now, speaking of our code, this code snippet has more to offer than these built-in library method names here. For example, I defined my own class and I named it dateUtil. Now, dateUtil is not too far away from this manager pattern, which I just said a couple of minutes ago that you shouldn't use. You should avoid names like database manager, remember? dateUtil is quite similar, but actually here it's really an exception. Naming classes like this, dateUtil, or also utility to be even more expressive, can make sense, especially if they mostly contain static methods like this one does. A static method, of course, is a method which can be called without instantiating the class first, like we're doing it down there. Then the class simply is there to group related functionality together, and then adding something like util, utility, or even manager in the class name can make sense to signal that this will not be instantiated, but that it's just a grouping of, well, utility or helper methods, like we have it here. So these are some exceptions and things to be aware of. Another exception can be seen in this code snippet, which now is written in TypeScript and therefore JavaScript. Here I have a database class which has a private property client, which is actually set when the connect method is called. However, since that property is private, it can't be accessed from outside the class. For that, we instead have this connected client getter. And getters and setters are special concepts which exist in multiple programming languages to provide you as a developer with greater control over how data in a class can be read or set. For example, a getter allows us to control access to certain properties in the class. In this case, we control whether the client is initialized before we return it. And here you will notice that even though connected client is written like a method, it has brackets and a function body, it actually has a name like a property. It's not getConnectedClient, but instead just connectedClient. Because actually this getter would be accessed like a property. That's just a language feature JavaScript offers, and many other programming languages have similar concepts. So for getters and setters, it is okay to use property naming rules, even though it's technically written as a method. But since we access it as a property, we should also name it as such. So that's another exception to be aware of. However, even with all these exceptions I just showed you, it should become clear and obvious that these rules which I outlined over the last lectures are super important and apply in the vast majority of cases. By now, we had a look at a couple of rules that you should consider when you pick names for your variables, functions, or classes. There also are a couple of pitfalls you should be aware of, a couple of errors which are easy to make. Now here's one thing which I already mentioned, but it's really important. Don't include redundant information in names. User with name and age is pretty bad if you create a user like this, because it's kind of obvious what's in this user, and if we would want to stick with this pattern, we could come up with super long variable names if that user would not just have a name and an age, but maybe also hobbies, a role, a first and a last name, and so on. You get the point. So this is too specific. Yes, names have the purpose of making us understand code without diving into the details of a certain implementation, but that does not mean that we want to describe everything with a variable name. This is too much information which doesn't help us. In most code snippets, it's probably enough to quickly understand that we're storing a user, not that it's a user with name and age. If we want to access that information, modern IDEs and editors will give us autocompletion anyways, and we can also simply expect certain fields to be in that object given the fact that it's named user. It's very likely to have a name after all. Hence, better names here would be just user, or if we want to be more specific because it makes sense, maybe it's a new user, because maybe this code gets executed in some part of our code where we are only operating on a newly created user, and that information might be important. Or maybe it's a logged in user and we want to reflect that, and we want to make sure that everyone reading the code knows that for this user you don't need to check whether he or she is logged in, for example. These could be variations which make sense. User with name and age doesn't make too much sense. Also avoid slang, unclear abbreviations, and disinformation. You want to avoid slang like this, for example. It might be funny to you, it might make sense to you, maybe also to you and your team, but overall it's not too helpful. And if I dive into this project and I have not been part of the team right from the start, I don't immediately understand what these methods are doing. Die please, for example, sounds like the product is about to be deleted, but I can't be 100% sure about that unless I dive into the code. So instead, don't use slang, use objective, clear names like remove or send error message here. Unclear abbreviations can also be a big issue. Consider these examples here. Message N, and then YMDT equals something. The second line is probably some date snapshot, but it's hard to reason about it. It's not clear what is what, at least not immediately. So here, clearer names help a lot. If we use new user instead of N, it's clear that we're sending a message to a new user and not to something. And if we name the variable date with time zone or something like that, it's also much clearer what's inside of that variable. Last but not least, disinformation should also be avoided. And I have seen code like this. We have all seen code like this. We maybe even wrote code like this. What's the problem here? Well, the first line of code has a variable named userList, but this isn't a list. It's a JavaScript object, or close to a Python dictionary. It's definitely not an array. There are no square brackets. All accounts implies that we have, well, all accounts, but instead it looks like we're filtering for certain accounts. So by definition, we probably don't have all accounts. At least it's misleading. So better names would be user map or just user if we store some object or map in that variable instead of a list. And filtered accounts makes more sense than accounts filter. Of course, depending on the application we're writing, we might also be able to replace filtered accounts with a better name. Maybe it's just the user accounts who have a paid plan. Then we could name it paid accounts, making it clear for what we're filtering. But it's all better than all accounts for sure. Also make sure that you work with distinctive names. Let's say you work with some analytics class which you used to create an analytics object. And now this class exposes a couple of methods to you. Get daily data, and you pass a day into the method. Get day data, get raw daily data with a day argument. Get parsed daily data with a day argument. What are these things doing? Don't write code like this. These methods all sound very familiar. It's very hard to tell what the different methods do and which method you want to use. And therefore, again, if you are the person diving into that code or working with that code, you have to dive into these methods first to understand which method you now need to call or what could be causing a certain bug. So instead use distinctive names, like getDailyReport, if this maybe doesn't return the data, but some PDF or Microsoft Excel report. GetDataForToday makes more sense than getDayData because it's clear that it's the data for today. GetRawDailyData makes sense, but now it doesn't clash with the other names because the other names are very clear and distinctive now. So now it's very easy to tell what the different methods do, and therefore working with this code becomes much easier. Now the last pitfall, or the last thing, the last concept to be aware of, is that you should stay consistent when naming things. For example, let's say you are writing a function which retrieves some data, let's say a list of users. You could name that function getUsers, fetchUsers, or retrieveUsers. They all kind of describe the same thing, and all three names would be fine. You can go with either of these options, but then stick with it. Be consistent. Throughout your entire program, always use the same pattern. If you went with getUsers in one place, also use getProducts in another place. And don't have fetchProducts in one class and getUsers in another class. It will not be obvious if these methods do generally the same thing, or if there is a key difference between getting and fetching in your program. So be consistent and stick to the names you go with. If you then decide that you don't like the name, you can always change it, but it will probably not be the get, fetch, or retrieve part which you don't like, but the part thereafter. And that's really it. These are the core rules, the core ideas and concepts, and the core pitfalls and problems you should be aware of and you should consider when naming things. So therefore, let's now dive into a couple of demos and of course also your challenge. So now that we got all the theory out of the way, it's time for some demos and for some bad to good code conversion, which we can do together for the moment. Your challenge will follow. Now you find this file attached, demo01 bad name examples py, holding some Python code, and you can download it. You can also run it if you got Python installed, but that is absolutely not something you need to do. We will only work on the code and try to transform it from bad code, from dirty code, to clean code. Now what's this program doing? We are defining some class here, a class named entity. It has a constructor function. This is how a constructor function is defined in Python. And this constructor function receives three main parameters. The self keyword is a special keyword and a special parameter in Python, which is basically the same as the this keyword in other programming languages. So we got three parameters which are being stored in properties of this class here. Then we got a function, not a method, but a function. If it would be a method, it would need to be indented differently. It's indented like this, so it's a function outside of the class, which takes an item and which then in the end accesses various properties on that item to simply print their values to the console. Now, the item clearly is an instance of this entity, since we are accessing title, description, and this strange property. Further down below, I then have a couple of variables with various values, which are being passed to the entity constructor to construct our item, which then is passed to this output function we just had a look at. So that's what the code does technically. Now, what is it doing logically? Well, it looks a little bit like entity in reality would be some kind of blog post. Because we have a title, we have a description, and we have something which is a date in the end. It's the date of today formatted as such a string, where we simply start with the year, then the month, then the day, hours, and minutes. So this here, in this example, should be a blog post. Hence, a better name than entity is blog post, describing what this class will be and which kinds of objects we can create with that class. Now, what about the parameters we get there? I think title and description are alright, but what about this YMDHM thing? This in the end is just the encoded version of our timestamp here, but this is of course not really understandable in human readable. In the end, it is just a date, right? So maybe we should name it date. If we knew which kind of date it is, we could also be more specific. For example, if this was the date on which this blog post was published, we could name it date_published, for example, or publish date. Both would be options you could go with here. It always also comes down to your personal preference to a certain extent. So I will name it date published, and I will assume that this is the published date. So then, of course, we need to adjust it here and here as well. I want to use that same name as the property name, and I want to store the value we receive on that parameter in that property. With that, this class doesn't look too bad. It's now way more descriptive already. Now what about output? In the end, this is just outputting the blog post, right? So maybe we should name it output blog post, or I personally prefer print over output. So print blog post makes it way clearer what this function does. And it's really only good at printing blog posts because we try to access blog post properties inside of the function. So a more generic name like just print data or anything like that would kind of be deceiving because it would sound like we can pass any data into this function when it will actually fail on any data which has not the structure of a blog post. Hence, I prefer the print blog post name. We can also rename the argument then and change it from item to post or blog post, whatever you prefer. And then, of course, we also need to use that name inside of this function. Now, this is also more readable, and we can now focus on the code down there. Now these names here are pretty much all messed up. Summary is at best okay-ish, but this is the title of the blog post. Why don't we just name it title? This would be way clearer. Desk, of course, is an abbreviation. Actually, it is an abbreviation which might be clear, but I personally prefer description. It doesn't leave other developers guessing whether that is a description or maybe some other kind of text. But I think desk would have been acceptable. Nonetheless, description is cleaner, in my opinion. Now what about this date? We are fetching the current date, as of today, with this code. Whether that makes sense or not is another question, but that's what we're doing here. Now the name new date is okay. It is a new date which we are generating, but maybe now or date today or just today, anything like that might be better. And I will go with now because it makes it clear that this is the current timestamp as of now, as of right now. Here, publish is a bad name. This sounds like a command, and we definitely don't want to name our variables like commands. Instead, as you learned, variables are data containers, and we want to describe which kind of data is in that data container. Here, it's the formatted date in the end. Now is the date, and we're formatting it here. Of course, here I want to use now, therefore, and here we could have the formatted date as a name. Because this describes what's inside of this variable. It's a date, and it's not just any date, but actually a formatted date, formatted in a certain way. Now down here, we previously used entity, the entity class. This is now the blog post class. So of course here it's blog post, and we pass in the title, the description, and then the formatted date. And it shouldn't be called item, of course. Instead, this is a blog post or just a post, anything like that. It depends on the context. We can go with just post here. Because of the surrounding code, it's clear that it will be a blog post. To be super safe, you could of course always go with blog post here if you wanted to. And then last but not least, here we have print blog post, and we pass the blog post to this function. And this is now a cleaner version of that code. It's definitely not the only way of rewriting that code, and you might come up with names which you personally prefer over the names I showed here, but you will probably agree that this code is now way more readable and meaningful and descriptive and self-explanatory than the code was before. Now this code which we just wrote, this code which we transformed from dirty to cleaner, could actually be improved even more to be even cleaner. Because the problem we have with this code right now is that we do have some redundancy or some aspects to it which I don't totally like. For example, this print blog post function. We have a blog post argument and blog post in the name. This is kind of redundant. But as I explained, just print data on the other hand would be too unspecific, and it would kind of signal that we can pass in any data when that's actually not true. A great way of enhancing this code even more would be to simply turn this function into a method of the blog post class by moving it into the blog post class, which in Python's case is done by indenting it. Now, that being a method of that class, it also needs to receive the self parameter as a first parameter. This is just a Python thing to unlock the self keyword in this method. And now we can operate on the properties of this class, and we don't rely on some input parameter anymore. So we can remove that and instead now simply access self.title, self.description, and here self.datePublished. Actually, that date name was something I forgot to replace in the last example anyways. But now we turned this into a method. And the advantage of this is that now we can simply call blogpost.print, and we can rename this to just print up here instead of print blog post, and then call just blogpost.print. And this is now very expressive and descriptive, I would say. It makes it very clear that we are printing that blog post. So we are outputting data about that blog post. And that's very descriptive and very easy to understand and read. So that's one easy way of improving this code even more. and you might find more ways of improving it. But that was one improvement I wanted to make, to also show you that sometimes it's not just about changing a name, but about changing something in code, which then thereafter makes naming automatically easier and more descriptive. And we'll see more of that later in the course once we also dive into functions and classes. But this was a first glimpse at something which sometimes is the best possible solution. Not messing around with the name, but instead moving it somewhere else in code. As we did here, where we turned this from a regular function into a method of the blog post class. Now that we saw many examples, learned about many rules, and saw a complete transformation step by step in action in the last lecture, it's time for your challenge. Time for you to apply what you learned. And for this, attached you find this example code, again written in Python, and again you can execute it, but you don't have to. Instead, you should understand what this code does, and then you should find all the places where you're not happy with a certain name. No matter if it's a class name, if it's a variable name, a function name, a method name, whatever it is. Now I will say right away, not all names in here are bad. There are names which are absolutely fine. You can still, of course, come up with other names if you prefer it, but of course, most importantly, you should focus on the bad names, and you should come up with better alternatives. Once you did that, have a look at my solution video to see which bad names I identified and which better names I came up with, so that you get a feeling for how I tackled and solved this. So in this code, we are working with some geometric objects. We got a point class, we got a rectangle class. At the end of the file, we are calling build stuff, where in the end we are constructing a point and a rectangle, storing both in variables. We then return the rectangle here, hence it's getting stored in my rect. And then I simply print the area of that rectangle, and I call the endpoints method in that rectangle class. That's what the code is doing. And there are a couple of names which are good and a couple of names which are bad. Now, good names would be point and rectangle, for example. I'm happy with these class names. You can always be creative and come up with other names, but I think these names are pretty straightforward and there is no need to change them. If we have a look at this constructor function in the point class, though, there already are names I'm not so happy about. And that would be chord X and chord Y. Now, the thing is, these names are not horrible. You can leave them. They are not bad. But they are also not great, because they do have a bit of redundant information attached to them. If the class is named point, and we do have a X and a Y argument, it's pretty clear what this stands for. It's clear that these are some coordinates. So this coord prefix is really redundant. We could just use X and Y here, instead of chord Y and chord X. There's no reason to keep that around. So I prefer this. And this is a rare case. Here I prefer the shorter version, the abbreviation, so to say, of a certain name instead of the longer form. But because X and Y are common knowledge, it's clear that we have X and Y coordinates in a coordinate system, and because it's in a point class, I think these names are super clear and actually more descriptive than the longer names, since it's less to read. Now what about the rectangle? The class name is fine. In the constructor here, again, I'm not too happy with all those names though. We got the starting point and then broad and high. Now, starting point could be okay. This is basically a point in the coordinate system where the rectangle would be drawn, or where the starting point of that drawing would be. It's therefore okay, but I think a better and more concise term could be origin. Now, again, this is up to you. This is not something you have to replace. Starting point would be okay, but I prefer origin because it is a bit more concise. Now, when it comes to broad and high, I'm absolutely not happy with these names. Broad and high, that is basically slang or some strange wording, strange language. It would be more appropriate to use something like width and height here. These are the proper measures which we're used to from other areas as well. Even outside of programming, we talk about widths and heights, not about a couch being broad, for example. So here I want to go with width instead of broad and height instead of high. This is definitely cleaner. Now what about the area here? This is a method in this rectangle, and typically methods should have a name that describes the operation which is performed. And area is not a command. It sounds like a property. Now property-like names could be fine if we would be returning a boolean here, or actually also if this would be a getter, which is a special kind of method. But since neither of the two things is the case here, I prefer getArea here, because that makes it clear that we can call this method to get the area of this rectangle, which is exactly what's happening. Of course, here, by the way, we should also use width and height since I changed these names up there. Now what about the endpoints? In the end, this method is printing a bunch of information about this rectangle. It's printing the x and y coordinates of the starting point, and then basically it prints where the rectangle ends on the x-axis and where it ends on the y-axis. And we also have these two helper variables here. First of all, of course, we should make sure that we also use width and height down there since we changed that. And here we changed starting point to origin, so we want to replace this in all 4 places as well. And chord x now is just x, chord y is just y, so we also need to adjust these things here. Now about the naming we introduce in this method itself, namely the top right and the bottom left name, which we introduce here and which we then use down there. Are these good names? I would actually say you can go with them. You will definitely also be able to find alternatives, which you personally might prefer, but these names are pretty descriptive. It's clear that this is the top right corner of the rectangle and that this is the bottom left corner. We could name it top right corner X or something like this, but this would actually be a bit redundant since the top right corner naturally only differs in the x value from the origin. On the y-axis, it's on the same level as the starting point, so the x-axis, the x value is the only point which will be different. For this, of course, you have to keep in mind that coordinate systems in programming typically start in the top left corner. And with that, it makes perfect sense to name this top right to indicate that this is the x value where the rectangle ends. But again, you definitely also can find alternatives here, which also could be fine. However, I will stick to these names and therefore leave this method as it is. Now for the rest of this code file. Here we got the buildStuff function. And as you can imagine, buildStuff is not a great name. This is slang and it's totally not clear what it's doing unless we look into it. A better name here would be buildRectangle, because this is what this function does in the end. It constructs a new rectangle by first of all building the origin point and then building the rectangle itself and then returning it. So build rectangle is a better name and should also be used down there. Now main point is also kind of a bad name. It's not clear that this will simply be the origin of the rectangle. So a better name might be rectangle origin, because that is what we plan to do with that point. It should be the origin of the rectangle. So let's name it as such and then use it down there. Rect is an abbreviation, arguably one which is clear, and still there is little that speaks against simply calling this rectangle. With that, I'm happy with the function and we can move down to the last lines. MyRect, of course, is a horrible name. I mean, what should this be? Is it the developer's rectangle? The rectangle of the user running this code? It doesn't make any sense. This should just be rectangle, or if you had some other more specific version, like user rectangle, then of course you should use that name. But don't use my rectangle or anything like that. Also not the rectangle. What would that be? Instead, in this case, I'll just go with rectangle, and then of course call rectangle getArea here, since we renamed this method, and rectangle endpoints down there. And actually, this brings me back to this method. One thing I forgot. Endpoints is a name you could keep, but we actually are not just printing the endpoints of this rectangle, but also the starting point coordinates. So actually, I personally think that a name like print coordinates is way better. It also makes it clear that we're printing something, which endpoints doesn't make clear at all. It does not indicate what's happening. It's already a bad name because it's clearly not describing a command. It sounds like a property. So print coordinates is way better. It makes it clear that this method will simply print all the key coordinates of this rectangle. Hence, this is the name I'll go with here, and this is now the name I'll use down there. And one other error I spotted here, which I of course also want to fix. Here I have self-height y. This of course is wrong. This should be self-origin y, and self-origin x down there, and self-origin y down there. I had a copy and paste error there. So now with that, this is the finished code, and we could now also execute it, which again you don't have to do. But if we do that, we get the area of this rectangle, and we then get the key coordinates. Hence, this is now the challenge solved. And of course, you will pretty much certainly have different names than I do. This does not mean that your names are wrong. I just walked you through my names and most importantly, for the reasons why I chose those names. If those reasons also apply for your names, if your names also meet the requirements and fulfill the rules outlined in this section, they are, of course, also fine. Ultimately, there will never be just one single correct name for something. There just are a couple of bad names, as you learned in this section.